This is Mr. Ashton going through the Mathematics Unit 2 Calculator Allows Higher Tier paper from the November or the autumn of 2017. The one thing I will say is that I've already done the intermediate paper, so there's a link below. So if you want to go through the first 8 questions or so, they're in the intermediate paper. Okay, so over the page, I'm going to go straight to page 12 and start on page 12. Okay, question number 9. It says, show that brackets 10w plus 3, close brackets, open new brackets, w minus 1, close brackets, blah, 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 is identical. That's what 3 lines across means, is identical to that. Basically, it wants me to go and simplify that, and they're telling me this is the answer I should get. Okay, so basically give me some nice, to get me the format, saying, look, this is what you're supposed to get at the end. So the first thing I'm going to do is use a bit of bid maths to work out these 2 times together, and then this thing, work out what that is squared, and then I need to take it away, okay? But it's a very tricky question because of where it comes with the squared and that minus. So the first thing I'm going to do is work out that front bit. So let's work out what 10w plus 3 and then w minus 1. Let's go and work out what that is. So that's going to give me 10w squared minus 10w plus 3w and then minus 3. Let's go and work out what 2 minus 3x squared, so that means times by itself, would give me. So that is going to give me 2 times 2, so that's 4. Then it's going to give me minus 6x, then another minus 6x, and then plus 9, not x, sorry, this should be w, sorry, that's a typo in my end, so these should be w's here as well. And then plus 9w squared. Okay, so that's what those 2 individual things give me. So that front bracket I can now write as 10w squared minus 10w plus 3w would give me minus 7w. And then minus 3 would go there. So I've dealt with that bit. I now want to take away all of this expression here. So all of that stays in a bracket, okay, for now, because of that minus up there. So we're going to have minus 6w would be minus 12w, and then plus 9w squared. Okay, now this is the bit where you're likely to have gone wrong, is that minus is effectively minus 1 times by each of these things. So we're going to get 10w squared minus 7w minus 3, nothing changed so far, but then minus 4 plus 12w, because a minus times minus is a plus, and then a minus times by a plus is a minus, and minus 9w squared. Okay, so now starting to collect the like terms. W squared, 10w squared, take away 9w squared is 1w squared, or just w squared. Minus 7w plus 12w would be plus 5w. And then minus 3 minus 4 would be minus 7. So therefore, this statement here is identical to that statement there. I'm going to say, therefore, 3 dots, 10w minus plus 3, w minus 1, take away 2 minus 3w all squared is identical to w squared plus 5w minus 7, as I've just got and proved. Okay, the question below tells me to go and use the quadratic formula. So if I go and get that from the front page, if I'm unsure, just have that above us there. It says, use the quadratic formula to solve this equation. Give your answers correct to 2 decimal places. Now, you're very lucky they told you to the quadratic formula. The big hint, if they didn't say that, was that you're on a calculator paper. It's come halfway through the paper and it wants it to 2 decimal places. So what we need to do is work out the coefficients a, b, and c. So if we look at the quadratic formula here, ax squared plus bx plus c, and then we use that formula. So a is the number in front of the squared term, so that's nothing, which means it's 1. B is plus 5, or just 5. And then C is minus 7, so I have to write in the minus for that. Okay, so now I want to go and write out the formula. So the best way to do that is using this formula here. I'm going to say x equals minus, and I'm just going to write it as open brackets with space to write in for now. That's all you have to do to begin with. So I've written this, I've written there, but with brackets. The first letter was B, B is plus 5, 5 goes in that bracket. Then it was B again, 5 in that bracket again. Then it said 4AC, so A was 1, so 1 goes in that bracket, and C was minus 7, so minus 7 goes in that bracket, and then A was 1, So A is 1 there. Okay, that's all you have to do to begin with. The next thing I need to do, I'll leave this out actually because I think it comes up later on. The next thing I have to do is actually go and work that out in my calculator. So the way I do it is once I will use the plus sign and once I will use the minus sign. So I'll say x equals, I get my calculator, I press my fraction button, I say minus brackets 5, I'm going to use the plus one first, plus the square root of 5 squared, minus 4 brackets 1 brackets minus 7, all over 2 brackets 1, and I get 1.14 to 2 decimal places. When I get a minus, I don't rewrite all of that. I use the replay button to come in at the start. I delete the plus sign, change it to a minus, and I get minus x equals minus 6.14 to 2 decimal places. Okay? Okay then, next question. Question number 10. It says, the line GH is a tangent to the circle at point Y. The line EF is parallel to line GH. The vertices of a triangle lie on the circle. Now, I tend to call that a cyclic, cyclic triangle. Okay, if we're looking at a cyclic triangle, then we should know that this angle here, using circle theorems, is the same as this angle up here. Okay, so what I'm going to do is go and write in this angle here is 60 degrees, and I know this angle. There's nothing wrong with drawing it into the diagram and writing your story here. Okay, this is 60 degrees because of, and what I need to quote here is the alternate segment theorem. Now that only works if you have a triangle whose vertices are on a circle and we have a tangent coming across. Okay, so that 60 is that. Now the next thing I'm going to use to try and work out some other angles in here is the fact that this is parallel to this. Now we don't usually get that. We have this time, so I can see that I can make a Z shape there, and if I can make a Z shape, then these angles here are the same. Okay, so the next angle I've made is that one there. Okay, so I need to state why that is. So I'll put a line pointing to that. I'm going to say this is because of parallel lines. This is because of parallel lines angles in a Z shape, which we should all know is alternate angles. Okay, alternate angles are equal. Okay, now finally, to work out, or I say finally, I'm going to go and work out this angle here now. Because this is a straight line, that's 60, that's 60, that must be 60 degrees as well. So I'll come point to that and say angles on a straight line. Add to 180 degrees. Okay, so 60 add 60 gives me 120, and then 180 take away 120 gives me 60 degrees for that one there. And let's just double check now that I have actually found what it wanted me to find. It says prove that EFY is an equilateral triangle. So I need to go and find this angle here. So then to find this angle here, we would do 60 add 60 is equal to 120. So then 180 angles in a triangle adding up to 180. Take away 120 is 60. So that is 60 degrees as it is the remaining angle. But there's no reason why we couldn't have used alternate segment then to prove that as well. If that angle and that angle are the same because of alternate segment theorem, so are those two there. Also, you could have used parallel line angles there. There's loads of different ways you could have done it. So I'm going to say, please see definitions with diagram. That's where I did a lot of my writing, so anyone marking my work knows where it is. Please see definitions with diagram. It follows that what do they call the triangle? EFY. EFY is equilateral. Okay then, over the page, question 11. Have a quick read and then I'll start going through it. Okay then, it says, a cone is joined to a cylinder as shown below. The cone has a base radius of 11. Now I'm going to go and draw that in. So that is what 11 centimetres is there. They usually put all this information in there, but they haven't this time. It has a slant height. Oh, right, sorry, that's the cone. So I should have written that in there, but I think they're the same because they're joined. It has a slant height of 13, so this is 13 centimetres here. That's the slant height. It says the cylinder has the same radius, so yeah, that 11 is fine, and a height of 17 centimetres. Calculate the total surface area. So they're not after volume, they're after surface area. So we've got to try and think about what these areas would look like individually, okay? Now, if I was to unfold the cone, it would make a shape that looks something like that, okay? If I was to cut down the cylinder and open it out, think you could do this with a toilet roll or a kitchen roll tube when you finished. You make a rectangle, fold that, it would make the circle, and then obviously you'd have the circle at the end. So there's 3 different areas there. Now, this was definitely the easiest to work out. This was the next easiest to work out, and this one's the hardest. But go and check your formula booklet, and we are told a formula to work out this curved surface area of the cone to work out this bit here. Okay, so let's start by doing that. So curved surface area cone. So the formula that I use is pi RL. So let's just check what that is. R is the radius, L is the slanted bit there, which they've told us. So the slant height is 13, so that's the L. So it's going to be pi times by the radius, which is 11, times by the slanted height, which is 13. Now, for all intents and purposes, just to leave this nice and easy into my calculator, if I put in pi brackets 11 brackets 13, you'll see that I get 143 pi. If I press SD, I get a horrible number. So let's just leave it in terms of pi for now, and we'll come back and finish that at the very end of the question. The next thing I'm going to do then is work out the rectangle. So the rectangle's dimensions, I know what that is. That's 17 centimetres also, it's the height. And this bit here is unfolding the circle, so it comes out as one long line. Now, that has got a description, the distance around a circle. The distance around the circle is the circumference. So the circumference formula I tend to use is 2 pi r. So to work that out, I want to do 2 pi r, which is going to be the length or the width of the rectangle, times by the height of it, which is times by 17. So it's going to be 2 pi times by the radius, which is 11, times by 17. Could say centimetres squared for that, as it's an area. So 2 pi brackets 11. Oh, hang on, I'm having problems with the brackets here. There we go. Times by 17, which gives us 374 pi. Okay, and again, that would be centimetres squared. And then for the area of the circle, check that you can see what I'm writing. For the area of the circle, we'll do pi times by 11 squared. So pi times by 11 squared would be 121 pi. Okay, so therefore, the total surface area would be 143 pi plus 374 pi and then plus 121 pi. So that's just going to go into my calculator like that. 143 pi plus 374 pi plus 121 pi. And that gives me an answer of 638 pi. But because I'm finished now, I will take that being out of pi form. So SD it to get 2004.3 to 1 decimal place. I'll just put in brackets there, 1 dp. So it's nice and clear to anyone looking at my work. Okay then, next question over the page to number 15. Says, number 12. The area of a rectangle is 137 centimetres correct to the nearest centimetre squared. Now, without going out any further, the fact that it said to the nearest centimetre squared, I can already tell you this is a question on upper and lower bounds. Okay, so upper and lower bounds, what I need to do is look to see what it says measured to the nearest and then halve it and take it off and add it on to work out what is the lowest bound, what is the lowest it could have been, and what is the highest it could have been. Okay, but let's actually read the rest of the question before I do that. It then says its width is 11 centimetres correct to the nearest centimetre. So again, there's that nearest bit. Calculate the greatest possible length of the rectangle. Give your answer correct to 3 significant figures. Okay, if it says the nearest 1 centimetre squared, to the nearest centimetre squared, it means the nearest 1 centimetre squared. So we're going to halve that, and we're going to find out that's 0.5 centimetres squared. So I'm going to say that the area could have had a lower bound of 137, take off that number, and the upper bound will be 137, add on that number. So 136, can't write at the moment. There we go, let's try and make sure that looks better. 136 or 137.5. Now, similarly, with the width, if we look at that to the nearest 1 centimetre, halve it would be 0.5 again. So then its lower bound width would be 10.5 centimetres. And its upper bound width would be 11.5 centimetres squared. Okay? Now, in terms of what they've asked me, they said calculate the greatest possible length of the rectangle. Now, you can either use a bit of logic, that's what I'm going to do first, but we can go about it in a slightly different way. What you tend to do is you tend to work at opposites. So it'll either be that answer and that answer working together, or it would be that answer and that answer working together. Okay, so if in doubt, try and work with the opposites. But it doesn't always work, but it's not a bad sort of trick to use if you're getting stuck. I want to know what the longest length of the rectangle was. Well, for that to happen, I want to work with the greatest length possible, or the greatest area possible, with the smallest width. So if I think about trying to work out the longest possible length that I could have had, which I don't know what it is, I'll just call it x for now. If that is as small as it possibly could be, so that number times by is bigger, to give me the biggest possible area, so 137.5. So what I want to do is 137.5 divided by 10.5. Okay? So 137.5 divided by 10.5 gives me an answer of, sorry, I've missed out the 1 there, 137. Now I've got a syntax error. What's going on here? There. I've got an answer of 13.095, blah, blah, blah. Okay? If in doubt, go and work out the other one. So 136.5 divided by 11.5. So the smallest it could have been was actually 11 point blah, blah, blah. It's got a smaller number, okay? So if it was asked what's the smallest it could have been, we work the other way around, okay? Now, final thing that I haven't actually dealt with yet was it said that it wanted this answer correct to 3 significant figures. So I need to round that to 3 sig fig. So first number is not a 0, so we started counting. 1, 2, 3 is the same as rounding it to 1 decimal place. 13.1 centimetres to 3 sig fig. Okay. Question 13 says, a bag contains 5 red counters and 5 blue counters. 3 counters are drawn at random from the bag. What is the probability that they are the same colour? So we could either have them as all blue. If they're all blue, I would have a 5 out of 10 chance of getting a blue, then a 4 out of 9 chance of getting a blue again, then a 3 out of 8 chance of getting a blue a third time. I'll work that out in a second. Similarly with red, I've got a 5 out of 10 chance, times by a 4 out of 9 chance, times by a 3 out of 8 chance. Work that out as well. They'll be the same number. So 5 out of 10, times by 4 out of 9, times by 3 out of 8. That comes to 1/12. This will also be 1/12, so exactly the same. Because there's 2 different ways I could have done it. It'll be 1/12 add 1/12, which is actually 2/12, but my calculator will tell me that it is 1/6 if I was to write it into simplistic form. Okay? Okay then, over the page, it then asks me to draw the curve of sine x. So my pencil, there it is. Okay, now I always look at the graph of sine, or the word sine, and the I in the middle looks like a 1. Ironically, this graph will start at 0. Cos, on the other hand, if you look at the middle letter, it looks like a 0. Ironically, that starts at 1. Okay? Now, for every 90 degrees, the graph of sine will rise 1 until it hits a peak of 1. So at 90, it will hit 1. And then, once it's hit its peak, it will now start dropping until it hits minus 1. Every 90 degrees, you lose a value. So 90 degrees on from 90 is 180, so we're back to 0. 90 degrees on from that, we hit minus 1. And now we've hit our minimum value, we're starting our way back up. Okay? So those are my key points there. And remember, it is a smooth curve. Okay? So it looks something like this. Okay? That's what the sine graph will look like. Something like that. We're then asked to solve each of the following equations. It says, give all of the answers in the range of 0 to 360. Where is sine x equal to 0.3? Now, the first thing I'm going to say is this answer here, this 0.3, we've got to go and find that on the y-axis. There's 1, 0.3 would be roughly here. I draw a line across until I hit my graph. There, you see it hits my graph in 2 places up to 360. Okay? So at 0.3, we're going to get 2 answers. Now, the way that we start working out those answers is by getting rid of the sign. So to get rid of the sign, we do the inverse of sine, which is called sine minus 1. So into my calculator, it's going to go sine minus 1 of 0.3. So shifting the sign, 0.3, and I get the answer x equals 17.5 degrees to 1 decimal place. Now, if we look at my graph there, that's clearly this answer here. Okay? Now, there is symmetry going on around the sine graph. Here, I know from 0 to this number here, there is a gap of 17.5. So coming back the other way, I would need to take away 17.5 from 180 in order to find out what this number is. So I'm going to do 180, take away 17.5, and I get the answer 162.5. Okay? So, or x equals 162.5 degrees. Okay? The next question says sine x plus 1 equals 0. So we start trying to get x by itself. So the first thing I'll do is get rid of that plus 1 by taking it away. I will now sine minus 1 of that, minus 1. And I'm going to find the following answer. Now I could use the graph here. 1. Oh, look. It only happened in one place. It only crossed it in one place, which is 270. So if I did sine minus 1 of minus 1, look, it gives me minus 90. It's actually telling me, if I draw this down here, if I did continue the graph here, it's actually telling me what this answer here is. So you have to go and use your graph to identify that it must be 270. Okay? Because it wanted the answer in between 0 and 360. So that 270 does do that, whereas minus 90 doesn't fit. Okay then, over the page, it says, let me move my camera, there we go, so you can see. It says 2 similar pyramids have volumes 3,970 centimetres cubed and 3,100 centimetres cubed, respectively. And the key word here is similar and volumes. You should know that the small volume times by the scale factor cubed will give me the large volume, or the big volume. Okay, so look at this, that's the bigger one of the two. We know that 3,100, the small one, times by the scale factor cubed, will give me the volume of the big one, so 3,970. So the first thing I'm going to do is start to rearrange that formula to work out what the scale factor is. So the scale factor will be the cube root of that fraction. Okay, they normally work out to be quite nice numbers, but they do look particularly nasty. So into my calculator, cube root of fraction 3970 over 3 100s. Press SD, I find out that the scale factor is 1.0859, blah, blah, blah. Now, I do not round that number yet because I haven't finished. Here is pyramid 1, the smaller one. Here is pyramid 2, it is slightly bigger. To get from that to that, I have times by the scale factor, for length that is, now, of 1.0859, blah, blah, blah. And to go the other way, I would divide by the scale factor in terms of if I want to find any lengths. If I want to find areas, times by the scale factor squared, divide by the scale factor squared. If it's volumes, times by scale factor cubed, divide by scale factor cubed. We're then asked, it says, the height of the larger pyramid, the height of the larger one, this guy, is 25 centimetres. So if we know this is 25 centimetres, how do we find the height of the smaller one? Well, we're going to work from this one, we are going to come here. So it'll be 25 divided by that scale factor. So divided by 1.0859, blah, 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 is equal to the height of the smaller one. So the height of the smaller one comes to, I put into my calculator 25 divided by ans, tells me it's 23.02. Okay, so that would be to 2 decimal places. Question 16. It says, each of the two graphs are described by one of the equations on the right. Put a tick in the box next to the one that describes each graph. Now, straight away, look at that. I can tell it's an x squared graph because it's like a U-shaped curve, but it is upside down. So this will be a minus x squared graph. It cannot be that. It could be that because it's got a minus in front of an x that is eventually going to be squared. It can't be that because the minus doesn't belong to the x there. It could be that, and it can't be that. Okay, right, so let's work out the other bits now. If we have an x squared graph, it looks like this. But if we have a minus x squared graph, it looks like that, upside down. And that's been shifted up 7 places. So it must be that one there, because if I look at my graph there, that's what minus x squared would be. If I put a 7 in front of it, it's going to shift that graph up 7 places to look like that. This would tell you, if I put in, yeah, that bit there, that would tell you where to cross the x-axis, okay? That effectively would do that, I think, for this graph, okay? So it's not that one either, okay? For graph B, now that is starting to rise up. Now you need to know that if you have a graph that does that, where it's starting to go up, it's what we call exponential growth. So we are looking to the power of x, okay? And there's literally only one there. It's just literally expect you to know the shape of that graph. Okay, we are on to the very last question now. Number 17. And number 17 says, ABC represents a sector of a circle with radius 7 and centre A is shown. BAC is x degrees, AD is 3 centimetres, and BD is 6 centimetres. So I'm going to start writing some of that information in. So this is 3 centimetres from A to D. This is 6 centimetres. And then, are we told anything else? I don't think we are here. Oh, hang on. Yes, because this is a radius of 7 there, then that must also be 7. So that means we know what D to C is. Okay, D to C must be 4 centimetres because 3 and 4 make 7. Okay, we're then asked to work out what is the shaded area. Now, if I'm going to work out the shaded area, I always try and write this in words so I have some sort of idea of what I'm going to be working out. The shaded area is going to be the area of the sector. So I'm going to say sector area. And it's going to be taking away this triangle here. Okay, so take away triangle, and the letters of that are A, D, B. Okay. Now, if I'm to go and work out, BDA. If I'm to go and work out what the sector area is, I need to know what that guy is there. Now, to do that, what do I need to get my head around to do? So we've got the area of the sector there. I know, I've got it. Okay, so we've got 7 there, we've got 6 there, and we've got 3 there of a triangle. we can use the cosine rule using a triangle. It stands to reason the last question is going to be using one of these guys here, sine rule or cosine rule. We're going to use the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. And the reason why we're going to use that is because we know all three sides and we want to know an angle. So that's when we use the cosine rule. If it was two sides and two angles, we would have used the sine rule. Now, because I want to know the angle, I'm going to rearrange to get the angle by itself, okay? So I'm going to bring the minus 2bc cos a over here. So it's going to be 2bc cos a is equal to b squared plus c squared minus a squared. I'm then going to divide b squared plus c squared minus a squared by 2bc. And that's going to be cos a, but then I'm going to take the cos over to the other side to get cos minus 1 of this to work out what the angle of A is. Okay, so I want to know what that is. So that's A, B and C are these other two sides. So A is going to equal cos minus 1 of B squared, so that's going to be 7 squared, plus C squared, so that's going to be 3 squared, minus the side opposite the angle we're after, so minus 6 squared, all over 2bc. Okay, so that is going to work out what the angle is for us. Seven squared plus 3 squared. I need to press the fraction button first. 7 squared plus 3 squared minus 6 squared over 2 brackets 7 brackets 3 is 58.41186 and so on degrees. You do not round the x, we haven't finished the question. So now we know what this angle here is. This angle is 58.4 blah blah blah. Okay, now we can start trying to use this. We can work out the sector area. We've got any space on the back? I'll have to try and fit it all on this page here then. So the sector area, so I'm going to say shaded area equals the sector area. So that would be the angle that we've got, so 54.411 blah blah blah, out of 360 times by pi r squared. So I'm going to say in brackets, so we'll say times pi, the radius is 7 squared. So that's going to work out the sector area. So that's effectively working out all of that. And I want to take away the area of the triangle. So to take away the area of the triangle, I then want to do a half AB sine C. So I'm going to say take away a half. Now A and B have got to be feeding into where the angle are. So it's going to be 3 and 7 that I use, okay? So it's going to be a half of 7, 3, times them together, sine, and that angle again. So sine 58.4 blah blah blah. Okay, so into my calculator in one long go now. I've got to be careful I get this correct. That angle there I'm going to use as ans, okay? So fraction, ans over 360 times by pi brackets 7 squared. And I then want to take away a half of brackets 7 brackets 3 sine ans. Same answer again. Press equals and I get the answer 16.0 centimeters squared to 1 decimal place. Okay. Just going to check that's right in the mark scheme. It's quite a tricky one that was not easy. Yeah, that's the correct answer. Okay. Hopefully you found that useful. If you have, please hit the subscribe button and you'll get first access as and when I record and release any more videos. Thank you very much for watching.